Hello, this is Jack Jackson. We're going to be looking at practice test 5A today. This test is intended to be done without a calculator, so that's the way we'll do it. I've pulled this up and just said to run the test without putting any answers in, so it's got all my answers marked wrong because I didn't answer anything. Just so that we can see the answers the computer has, check them against what we're going to be doing here in the solutions. So we're going to go through here. This might be broken up in more than one video, or it may be just in one video. We'll just see how the time goes here. So we have 20 questions here. We're going to start with number 1. 5x squared equals 15. We want to solve this equation exactly. Well, we want to try to get the x squared by itself, so we divide both sides by 5. And that cancels that out, so you have x squared equals 3. 15 divided by 5 is 3. And now we take the square root of both sides, and when we do that, the left side really becomes the absolute value of x. So what we really get is x is plus or minus the square root of 3. Of course, you can go straight from here to here if you want without writing all the absolute value down, if you remember that requires you to put a plus or a minus. And of course, notice that they both check, a positive or a negative square root of 3, either one. When you square it, you get 3. Multiply by 5, you do get 15. So that does check. And so you want plus or minus the square root of 15. Of course, you'll have to use the little symbol palette over here for that. Question number 2. 2x squared plus 10 equals 0. Again, we want to try to get the x squared by itself. So we're going to subtract 10 from both sides. 2x squared equals negative 10. Divide both sides by 2. X squared equals negative 5. This time I'm just going to go straight to plus or minus the square root of negative 5. Now the square root of negative 5, square root of 5 we can't simplify, but the square root of negative 1 is our imaginary number I. So we get plus or minus that. That's really two answers. In other words, x equals square root of 5I, or x equals minus square root of 5I. So we're going to enter those in, well, like you see them there on the calculator, on the computer. Next question. Okay, so this is a cubic equation. We should be looking for 3 solutions. Now, some of them may be the same ones multiple times, but possibly 3 solutions. Okay. So here we want to try to see if we can do a little factoring, if we can. Well, notice this doesn't have a constant term, so I can factor a y out. And then I want to see if I can factor this, and I could either use the quadratic formula if I can't factor it, or I can't see how to factor it. I'm going to try just the anti-full trial and error. So to get 2y squared, I got to get 2y and y. To get negative 9, I need 1 and 9, or 3 and 3, 1 positive, 1 negative. And we got to get 17 out of that. Let's see. 9 times 2 is 18. Let's see. And then 1 here. That would be 17. I want it to be negative, so I need the 18 to be negative and the 1 to be positive. Okay, let's check that out. 2y times y is 2y squared. 1 times negative 9 is negative 9. Doing FOIL here. Negative 9y times 2y is negative 18y, plus 1y is negative 17y. Then distribute the y, and we're back to where we started. So now I have a bunch of things multiplied together that are equal to 0. It's very important that is 0. So now we can set each one of them equal to 0. This means y equals 0, or 2y plus 1 equals 0, or y minus 9 equals 0. So y equals 9, or subtract 1 and then divide by 2, negative 1/2, or y is 0. So those are our choices. We'd write it this way: y is an element of the set 0, negative 1/2. 9, that's kind of a sloppy looking brace. Let's fix that. Now, to put it in the calculator, well, the computer, you just put it like this: 0, 9, negative 1/2. You should be able to do that in any order of the 3, hopefully. Okay. If you have one like this that is a third degree or higher, well, any kind of equation you're going to have to solve here, you should be able to factor it out except for maybe the quadratic part. And you might have to know how to use the quadratic formula in some cases to find those. We didn't need it on this one. We were able to do it completely by sort of, Algebra 1 type factoring. The next one we have question 4. We have 2x squared minus 5x equals 1. Again, we want to get 0 on one side, and we get 2x squared minus 5x minus 1. We might try the trial and error factoring. Let's see if it works. 2x, they've got to be 1 and 1, one positive and one negative, so this gives us 1x and 2x. When we subtract, we're either going to get positive or negative 1x because they've got to be opposite signs, and we're not going to get 5x. So that doesn't work. Okay, so since that didn't work, we need to factor it by using the quadratic formula. Okay, so the quadratic formula says our root 1 and root 2 are, in other words, x, our root 1 is minus b over 2a plus or minus the square root b squared minus 4ac over 2a. I like to put it in two fractions like this because this first part is just h, and this next part is how much you go left or right from h to find your roots. Remember, h is the x-coordinate of the vertex, and of course this is ax squared plus bx plus c equals 0 to make this happen. Okay, so now we just plug in the numbers. The negative's built in, the 2's built in. Here's where we put numbers in. Let me sort of put the parentheses in, then I'll go back and put the numbers in. So all that's built in. And the numbers we put in, let's see, a is 2. So everywhere we see an a, we put a 2. That's here, here, and here. B is negative 5, and that shows up here and here. And C only shows up once. It's negative 1, and it shows up right there. Alright, now let's do a little simplifying. 2 negatives make a positive here. 5 on the numerator, 4 denominator. So 5/4 is the x-coordinate of the vertex, or x equals 5/4 is the line of symmetry, the mirror line. Over here we still get a denominator 4 as well. This is 25. 2 negatives make a positive. 2 times 4 is 8 times 1 is 8. So that's positive 8. 25 plus 8 is 33. And we do it like that. Most people will go ahead and write this with a common denominator. So I don't know if it will take it in this form here. So let's go ahead and put it like this, which really means there's two answers. Either x equals 5 plus the square root of 33 over 4, or x equals 5 minus the square root of 33 over 4. And those are exact answers. If this was in the calculator section, of course we could approximate this by plugging this in a calculator and get a decimal. Of course, if it was in the calculator section, we could have just graphed y equals this and see where it crosses the x-axis, and as far as an approximate answer. But these are exact answers, and notice that does agree with what they have there. So yeah, you do need to memorize the quadratic formula, either in the form I have it or in the form that's often seen in, where it's all over one denominator of 2a. So you can do that if you want, but you do need to memorize that. Hopefully you've seen that and memorized it from classes in the past, but if not, you need to do it for this class. Next, we want to graph a function. F of x equals x squared minus 4x plus 3. So first of all, realize this is a parabola, so when you do this from the graphing tool, don't know if I can get this to come up with the graphing tool here. But the graphing tool, you'll have to click on the one that looks like a parabola. Okay, click on that, and you'll have to specify some points here. Okay, and honestly, I don't remember how this one, the parabola tool, if it works by clicking on the vertex or the points. But let's talk about some key points that you would have. Okay, first of all, right from this form, okay, you're going to have the point 0, 3. That's going to be your y-intercept. Okay, we can also just plug in some numbers, of course, and get a table of x and y values, which is certainly very doable. Let's also talk about the other forms that we could put this in. Can we factor this using just good old trial and error kind of factoring? Yeah, it's x minus 3 and x minus 1. So the only choices for x squared were x and x, and for 3 it had to be 1 and 3. They both had to have the same sign because that's positive. The sign had to be negative because of that. And sure enough, it works out. So this tells us that 3, 0 and 1, 0, the things that make these 0, are the x-intercepts. That should be more than enough to nail it down, because once we have those 3 points, that will definitely do it. Notice that the coefficient a is 1 here, so this is exactly the same size and shape as a y equals x squared. Now, what about a vertex form if we need the vertex? Okay, we can do the vertex a couple of ways. There's a couple of nice forms for the vertex. It's minus b over 2a, and it's also root 1 plus root 2 divided by 2. So, the minus b over 2a part would be b is negative 4, a is 1, and so this turns out to be 2 when the dust settles. But it's also the same as if you just average the two roots. 3 plus 1 divided by 2 is 2. Halfway between 1 and 3 is 2. So we see that it's still 1, x minus 8, so it's x minus 2 squared. And now we need to find k, and we could do that by plugging, it's just f of h. K is f of h. So, in other words, it's f of 2. We just plug in 2, say in our original, 2 squared minus 4 times 2 plus 3. That's 4 minus 8 plus 3, that's negative 1. So we have minus 1 here. So the vertex is 2, negative 1. So there's some interesting points there. Of course, we could have gotten all of these points by just making our table go, 0, 1, 2, 3, and figure out x's and y's. But now we know that not only, of course, once we saw that these were both 0, we knew the one halfway in between would be this. So this one, x is 0, we know that's a y-intercept. When we saw these as y is 0, we could have just stumbled on them. That would be x-intercept. And of course, halfway between, that's going to be the vertex. So those are kind of our key points. But anyway, whatever it asks you to do, you can, if it needs you to find the vertex, we can do that and use it from there, and so forth. Or if we need to know it from the intercepts, we can do it that way. But in any event, manipulate the graph till you get that one to work out. Okay, next we're at question number 6. For the function below, find the vertex, axis of symmetry, minimum or maximum value of the graph of the function. Okay, so again, let's go ahead and figure out all 3 forms here just for practice. From this, we can see that 0, 6 is the y-intercept. Now, to find the vertex, we want to find h, which is minus b over 2a. That's the x-coordinate of the vertex. So that is, remember, this part's built in. We just have to fill in the a and the b. The b is 2, the a is 1. That reduces to negative 1. So negative 1 is the x-coordinate of the vertex. Okay, and so this is still 1. So this is 1, x minus a negative 1, or x plus 1, square. Okay, and then we got a plus k here. We'll substitute what k is here in just a minute. Okay, so now how do you find k? Well, k is f of h, so that's f of negative 1. So take negative 1 and plug in the version we have there and work this out. 1 squared is 1. 2 times negative 1 is negative 2. That's 6. 6 plus 1 is 7 minus 2 is 5. So 5 goes right there and right here, so that negative 1, 5 is the vertex. I believe that's the first question they asked. The axis of symmetry then is x equals h. So the axis of symmetry is x equals h, or x equals negative 1 in this case. Now, A is 1, so that means it's opening up, and it's exactly the same size and shape as the y equals x squared. It's just been moved, well, 1 to the left and 5 up, actually. Okay, and so, and actually if it's been moved 1 to the left and 5 up, see, on some scale this is negative 1, this is 5, that's not square scale, but the graph's going to look, sort of kind of like that. Okay, and it crosses the axis here at 6, which I definitely don't have it to scale, or like that on the scale that I'm looking at. It's kind of a sorry drawing. Neat. Okay, so anyway, something kind of like that. Notice it doesn't have any x-intercepts, so if we do factor it down here, we're going to have to factor it using the quadratic formula, because these roots will have they'll have an I involved in them, something plus something I. Well, it'll be h plus something I, so it'll be negative 1, so minus negative 1 plus question mark I, and this will be minus negative 1 plus question mark I. What's question mark? Question mark is the square root d over 2a, square root of b squared minus 4ac over 2a. We could work that out and get that if we need it. We don't need it in this case, so I'm going to stop there. But this vertex then, since it's opening up, how we know it's opening up? Because the a right here in all three forms is positive, so it's opening up, then that means that's a minimum. The minimum value is actually the y-coordinate, the k, which is 5. So which one of these fits? Here's a graph that actually looks right. C. There we go. Notice it goes through, notice this is going up by 2's on a grid. So halfway between here would be negative 1. You go up to 4 and then a half, that'd be 5 right there. And there's your vertex. Goes through here at 6, 0, 6, opens up. There we go. That's a vertical line, definitely not. These are parabolas. That's probably just y equals x squared there. Yeah, it looks like that's y equals x squared. This one's been shifted the wrong way. This is right and down. This should be shifted left and up, which is correct. Alright, we're up to number 7. F of x equals negative x plus 6 squared minus 9. From this we can see that the vertex is negative 6, negative 9. Remember, this is the form a x minus h squared plus k. So remember, h will, because the minus here, this is minus a negative 6, so negative 6 is h. But k is just plus k, so it'll be whatever the sign is here. So this is plus a negative 9, so that'll be negative 9. So there's the vertex, and the a, notice, is negative 1. So it's opening down. So it's going to go through, well, that's alone is enough to be able to narrow it down to D, because negative 6, negative 9 means the vertex is in the third quadrant over here. So that narrows it down to this one or this one. It's opening down, so that's got to be this one right here. It's got to be D. We could also, since it's down the third quadrant opening down, it doesn't have any real roots, or in other words, it doesn't touch the x-axis, but it does, of course, it would have two complex roots that are not real. And of course, we could work this out and pretty easily find the general form, which would tell us the y-intercept if we need it. Of course, we can just plug in 0 and work that out if we needed to as well to find the y-intercept. That was all screen anyway, so the y-intercept didn't really help us. Number 8. Classify the constant linear quadratic cubic quartic. Okay, that's 0 degree, 1st degree, 2nd degree, 3rd degree, or 4th degree polynomial. Identify some things here. Okay, so so you're looking at the highest power is what you're looking at here. So the highest power is 4, so that's quartic. Okay. What's the leading term? That's going to be the whole term that has the biggest power. So this was negative 3x to the 4th. And in fact, if you graph y equals negative 3x to the 4th, and you graph y equals negative 3x to the 4th minus 8, any polynomial that starts with this and then has other terms, this power function here will describe the end behavior. So it looks kind of like this on the ends. Not so much necessarily here. In fact, this one it does because it's just been shifted down 8. So the leading coefficient then is going to be the negative 3, and the degree is the power there, which is 4. Okay. Describe the end behavior. Well, the only thing that matters on the end behavior is that first term, well, if it's in decreasing order, so that leading term. So the power function, f of x or y, equals square root of 5 times x cubed is going to be what it looks like on the end. Well, we know x cubed looks like this. Square root of 5 times that's going to maybe expand it a little bit, but it's still going to have that same basic shape. So it's going to look like that on the end. So on the far right, it's going to be increasing concave up. On the far left, it's going to be the arrow. You're going to think of the arrows pointing down, but it's going to be actually increasing as we go left to right, concave down. So anyway, you want the arrows that look like this, and that's D. And really, those arrows there they have are the 4 possibilities. The first one is when the power, the degree, is even. The arrows will point the same way, like A and C. And the arrows point the opposite way, B and D, when the degree, the power, is the biggest power, is odd. Arrows point down on the right, like A and B, when that leading coefficient, the coefficient here in front of that power, is negative. And it'll point up on the right, like D or C, when that leading coefficient is positive. So, same thing here. So, you only have to look at that first term, and this will determine the end behavior. And notice even power says the arrows are the same way. Negative coefficient says down on the right. So it looks kind of like that on the end. This is concave this way and this way a little bit. Okay, in the middle could have lots of ups and downs. Could cross the axis up to 6 times. Could have up to 5 in extrema. Could have up to 4 inflection points. We don't know till we would get a more detailed graph. But we do know the end behavior, and that's D. And not only do we know that the basic shape is like that, we actually know it's along the speed of an x to the 6th. So as compared to not, the basic shape would be the same if this was power 4 or 6 or 2, but the speed of it is a little different. So if you graph those together, you'd see that. That was question number 10. Let's just keep going here. Which one of these is the best graph? Well, y equals x cubed minus 3x squared minus 6x plus 10. Now these are considerably different in the shapes. So a couple things we can tell right off the bat. A y equals x cubed, it starts with an x cubed. Okay, let's talk about the end behavior first. That's a power 3, so well, first of all, it has a positive leading coefficient. So that says the arrow on the right side is up. It's an odd power, so the arrow on the left is down. Well, that automatically eliminates, well, in fact, that does it. That eliminates A and C. That only leaves B. Let me also talk about A. A could not be a cubic. Notice it has 4 X-intercepts. It's got to be at least a 4th power. Whereas B and C could be 3rd power because they cross the x-axis 3 times. So those are possibilities. So notice we didn't have to have a calculator to graph this. We didn't even have to actually graph it at all. The end behavior in this particular case allowed us to work it out. Also, we could eliminate A because of the roots. Now, if you'd had this, for example, as one of the choices, for example, the end behavior is right, but there's too many roots. Too many roots, too many extrema. There's no way that could be a 3rd power either, right? Because the 3rd power is going to go 1 max, turn around, 1 min. Or perhaps just 1 inflection point. Those are really the only choices. Okay. 12. Find the zeros. Well, if it's already factored, defining the zeros is easy. X minus 5 to the 4th, x plus 1 cubed, and x squared. What makes each of these factors 0? 5 is the one that makes that 0. Negative 1 is the one that makes that 0. And 0 is the one that makes that 0. In other words, 5, 0, negative 1, 0, and 0, 0 are your x-intercepts. So these are called the roots, or they might be called zeros. Roots or zeros. Now we also have the multiplicities of them. The multiplicities are the corresponding power. So 5 has multiplicity 4. Negative 1 has multiplicity 3. And 0 excuse me. 0 has multiplicity 2. So the 0, 5 has multiplicity 4. The one that's multiplicity 3 is negative 1. And the remaining 0 is 0, and it has multiplicity 2. And this tells us something about the graph. It touches the axis at 0, 0. At 5, 0. And at negative 1, 0. Now, we know the end behavior. If you work this out, the first term is negative 9x to the, 4, 5, 6, 7, 8, 9, plus some other stuff. So we know eventually it's going to go down on the right, and we know the opposite arrow over here. Furthermore, we know that when it comes into 5, to negative 1, let's do that one first, it's an odd multiplicity bigger than 1. So it's going to level out but have an inflection point there and a horizontal tangent line as it goes through. Okay? Now, so then it's going to, somewhere in here it's going to change concavity and turn around and come back up to 0. 0 is a multiplicity 2 root, so at 0 it hits and turns around. Comes back down here somewhere, comes up to 5. 5 is a multiplicity 4 root, an even root, so it hits and turns around. Now what I don't know is how far down this goes, how far down this goes here. But as far as the turns and so forth, I know, and the shape near the axis there, I do know we get that kind of shape there, this kind of shape here, and this kind of shape here. So I know a lot about the graph even without picking up a graphing calculator, or without even plotting any points there. 13. F of x is 1/4 x to the 5th plus 9x squared. So without graphing this, well, I don't really know how many intercepts or maxes or mins or whatever it has. That's not what they're talking about in this question. They're saying just based on what you see about the degree, really. The degree is 5. So just based on that, then it could have 5 zeros, or roots, x-intercepts, up to how many? 1 minus that, 4 extrema, that's what they're calling turning points. and up to 3 inflection points. Okay, so how many real zeros could it have? Up to 5. It may have less than that, but it's no more than 5 for sure, just based on the degree only. Okay, now in reality this one may actually have less than that, but the degree only tells us it's got to have 5 real zeros and 5 intercepts at most, and at most 4 turning points. Alright, which one of these goes with this graph? So we have h of x equals x times x minus 1 times x plus 1 times x minus 7. So what makes these 0? So 0, 0, 1, 0, negative 1, 0, and 7, 0 are our x-intercepts. So that means 0, 1, negative 1, and 7 are our roots, or sometimes we call them zeros. Roots or zeros. Okay, so we're looking for a graph that crosses at these points. If we work it out, the first term is 1, 2, 3, 4 x's multiplied. It's x to the 4th. So we also know the end behavior is like this at the ends. So we know it goes up here, and we know it crosses the x-axis at negative 1, 0, 1, and 2, 3, 4, 5, 6, 7. And they're all they are all simple roots. In other words, multiplicity 1 roots. So it goes through kind of like a straight line here. So that must mean this one's going down. It'll turn around somewhere. Don't know how far down. In between here, it's got to turn around. Somewhere in here, it's got to turn around. So overall, it looks kind of like that. The size of it, I don't know. Some of it may be off screen. So which one of these looks like that? Well, let's see. It's got to go through negative 1, 0, and 1. It's a little hard to see right in here. Let's look at a bigger graph. Okay, this goes 2, 4, 6, 8, 10. Looks like this goes through negative 1, 0, 1, and 7. So it's going through all the right places, but the direction's wrong. See, when we took into account our end behavior and where the turns had to come, we could see that the direction's going the wrong direction. So that one's not good. Let's look at this one here. This one doesn't go through 0, 0, so that's out. Let's look at the last one. Okay, this one goes through 0, 0, but it looks like a multiplicity 2 root there. It's turning around, so our directions are not quite right on this one either. Okay, our end behavior, for example, is not right. How about this one? Alright, this one agrees with what we've got. It's got negative 1, 0, 1, and 7, and it's going straight through. It's going up on the right, down on the left, so it looks something like that. So it looks like my part over here in my graph here with this minimum was much lower. Not surprising, but there we go. Okay, we're up to number 15. Okay, another one that's similar to this. F of x equals 1/2 x to the 6th plus x to the 5th. If we factor out an x to the 5th, then we've got let's factor out a 1/2 x to the 5th. Let's just leave it like that. And then that leaves x plus 2. So distribute that back out and you'll see that that gives you the same thing that we have up here. Okay, so our leading coefficient is 1/2, and our total, okay, so just looking at this says positive leading coefficient up on the right, even up on the left, so that's going to be useful for us. Furthermore, we see that the X-intercepts, this one tells us it goes through 0, 0. And this one tells us it goes through -2, 0. Right there and right there. Now, we know eventually after it goes through this one, it's going up. So it's going up this way. But that's an odd root. So that's an odd multiplicity root. So it's looking kind of like this near that root if I zoom in close enough. And then somewhere it's going to got to turn around, come back up to here. This one is a multiplicity 1 root, so it just kind of goes straight through there. So it's going to have that basic kind of a shape to it. So let's see which one of these we can look at and see. Okay, this first one, the arrows on the end are going the right way, but it doesn't go through 0, 0. So that's definitely a no. Okay, how about the next one? The arrows on the ends are going the wrong way, and it's a little hard to tell what's going on right here, but it doesn't look like what we're looking for here for sure. Okay, how about the next one? Okay, again, the arrows on the end are going the wrong way. We're going the wrong way through this point at -2. Okay, so that's no good. The last one, hopefully this is it. Yeah, this looks kind of like what we have here. There's your -2. There's your 0. At 0 it comes up, flattens out, and goes through. At -2 it's kind of going straight through. Okay, somewhere in between in here there's a minimum. It's a lot closer to the axis than I've got it, but there it is. And overall the arrows are up on both sides. Yeah, that one looks pretty good. Of course, we could plot some more points too. Notice I did this without plotting any points besides the roots, but of course I could have, if I'm still in question, I can just make a table of x's and y's and check it that way. Okay, so find the remainder with synthetic division. Of course, you can also do long division with this. But synthetic division, we write our coefficients here, -7, then the coefficient of the x, then the x squared, and then the x cubed. Out here we put the opposite of what you see here. In other words, what would make this 0, -2. You bring down the 1. 1 times -2 is -2. And we add and get -5. -2 times -5 is +10. Add and get 10. -2 times 10 is -20. And add and get -27. So this says that if you take x cubed minus 3x squared minus 7 and divide it by x plus 2, what you get is this one right here is a constant term, 10 plus -5x plus x squared, and you could say plus a -27 over the x plus 2. So the quotient is here. This is the quotient, and this is the remainder. So the quotient is x squared minus 5x plus 10, and then it's -27 there. Of course, you could also do this with long division, put the x plus 2 here, and the x squared minus 3x, x cubed minus 3x squared plus 0x minus 7. Got to be sure you leave that spot for that here. And you could do this out with long division also, and you're going to get, ultimately you'll get the same thing, x squared minus 5x plus 10, and a remainder down here of -27. I'll do it this way too. X cubed divided by x is x squared times x is x squared, and x squared times 2 is 2x squared. Change the sign, use the change sign to add, that cancels. This is -5x squared plus 0x. -5x squared divided by x is -5x. Multiply, we get -5x squared minus 10x. Change the sign and add, we get 10x minus 7. 10x divided by x is 10. 10 times x is 10x. 10 times 2 is 20. Positive. Change the sign and add, and you get -27. So that's the remainder, and this is the quotient. One thing that's also really interesting about this is this -27. Look back at this version of the formula here. If I how would you check this? You could check this by saying x squared minus 5x plus 10 times the x plus 2, and then add the negative 27 should be not 0. It should be the what we started with, the x cubed minus 3x squared minus 7. So notice if I were to plug negative 2 into this formula here, that part becomes 0, and so you get negative 27. So that means if I plug negative 2 into the right side, I'm also going to get negative 7. So let's work it out. Negative 8, that's positive 4 times negative 3 is negative 12. It's negative 20 minus another 7 is negative 27. So this gives you an alternative way. So this synthetic division gives you a nice way of taking this function. So if I said f of x was x cubed minus 3x squared minus 7, now I've got two ways to do this. If I want to do f of negative 2, I can actually plug it in like I did down here to get f of negative 2 is 27, negative 27. Or I could do this process here and get it. So that's a different way to do that. Next question. Talk about asymptotes here. F of x equals x minus 5 over 2 minus x. Okay. First of all, let's talk about the domain here. The domain is going to be all reals except for things that make the denominator 0. So if 2 minus x, is equal to 0, we've got a problem. So 2x cannot be 0. Add x to both sides. 2 cannot be x. So the domain is all reals except for 2. Now you reduce this and simplify it. Usually I would write it as factor negative 1 out of the bottom. So that's in decreasing order. But nothing will cancel here. So that means that x equals that 2 is a vertical asymptote. Now what about a horizontal asymptote? If you put them in decreasing order and you just look at the first terms, you get a power function. It's x over minus x, which reduces to negative 1. So that means y equals negative 1 is what it's going to look like on the outside ends, which means that's a horizontal asymptote. Now this one only asked about vertical asymptote. There it is, x equals 2. Horizontal is y equals negative 1. So vertical asymptotes are when x equals a constant, vertical lines, and they will be x's values where the denominator is 0 in both the reduced version and the original version. How about this one? Does it have any vertical asymptotes? Okay. 2 over x plus 4, x minus 1. So again, we look at what makes the bottom 0, and we see that if x is negative 4, or if x equals 1, that's what's not allowed. So the domain is all reals except for those guys. Or in interval notation, that would be negative infinity to negative 4. Skip over the negative 4, go to negative 4 to 1. Skip over the 1, go to 1 to infinity. But we know that we have asymptotes at both places because there's nothing that will reduce here. So those are both vertical asymptotes. X equals negative 4 and x equals 1. C is the answer there. Next, just a couple more. F of x equals 3x cubed plus 5 over 5x cubed minus 2. Okay, so if we want to do horizontal asymptotes, we look at what happens here. Let me back up to the last one just a second. what does the end behavior work out? Well, if you work this out, this is 2 over x squared. Really, that's the only part I need to know. But minus 3x minus 4. If you look at the first part, p of x equals 2 over x squared. In other words, 2x to the negative 2. That's what's going to look like on the ends. So notice that anytime you have the power bigger in the denominator, ends up with a negative power here, a bigger power in the denominator, then your axis is going to be, your x-axis is going to be a horizontal asymptote. So y equals 0 is a horizontal asymptote. This is on the last problem. And not only does it do it, it does it like a 2 times x to the negative 2. That's a positive leading coefficient, so it's not been flipped. 1 over x squared comes in like this. Here, has an asymptote here, but comes in here. So we know it looks like that on the ends. Furthermore, we know at negative 4 over here, it has an asymptote, so it must be going like that. And at 1 it has an asymptote, so it must be going here. What I don't know is what it's doing in between. Notice that it doesn't actually ever cross the x-axis because the numerator is never 0. So it's either, I don't know yet, I'd have to do some, it's either down here or it's up here. I'd have to, it's going up like this, or it's down here. I need to plug in some points and see. We could plug in 0 real easy and find out. If I plug in 0, I get a negative 1/2. So it's actually this one down here. It's actually, everything's below the axis in between these two. So roughly speaking, we get a graph, somewhere along the lines of, it's down here, asymptotes this way, here, and here. So I know I have a roughly that kind of a shape. Again, notice I only really plotted one point. Of course, I need to plot lots of points to really get what the graph really looks like, and then that's when a calculator really comes in handy. Now here, if I want to find let's talk about the domain and the x-intercepts first. If the 5x cubed minus 2 is equal to 0, we've got a dividing by 0, which is not allowed. So that's not allowed. So 5x cubed cannot be 2. X cubed cannot be 2/5. So x cubed, x is not the cube root of 2/5. Okay? And we can rationalize the denominator if we want. Why not? Multiply by 5 squared over 5 squared. That's 75. Cube root is 75 over 5. Okay? So x equals that. So x equals cube root of 75 over 5, or cube root of 2/5. That is a vertical asymptote. Okay, because it's not going to make the top 0 too. Now what about end behavior? End behavior is determined by what I have in the box here, the first term. So what is that power function? It's 3x cubed over 5x cubed. Well, when the powers are the same, this cancels out and you get a constant. That means that y equals that constant is what it's going to look like on the ends, so that's a horizontal asymptote. So when do you have a horizontal asymptote on these? If the power is bigger in the denominator, then the x-axis, y equals 0, is a horizontal asymptote. If it is a what am I saying? If the power is the same in the top and the bottom, then you get y equals a constant, and that is y equals that value is a horizontal asymptote. If the power is bigger in the top, it'll look more like a positive power function on the end, so it will not have horizontal asymptote. One more question. Finish this up. F of x equals x squared minus 8 over 7x to the 4th plus 2. Well, it's just asking about horizontal asymptotes, so let's look at that first. So here we have, on the ends, it's going to look like x like this. This as a power function is 1 over 7x squared, or 1/7 x to the negative 2. And we know what that looks like. X to the negative 2 on the end looks like this. It's not been flipped. and it looks like this. So now so y equals 0 is the horizontal asymptote. Power is bigger in the bottom than the top. It's always y equals 0. Okay, but not only do we know it's y equals 0, we know on the far right it'll always be above the x-axis, getting closer and coming down closer and closer. On the far left, as we go from right to left, it'll be below the x-axis, coming up there, or decreasing function there below the axis. In between, who knows? Okay. While we're at it, let's go ahead and figure the domain and if there are any x-intercepts. We're looking at what makes the bottom 0 for vertical asymptotes. Not x-intercepts, sorry, vertical asymptotes. So we're looking at what would make 7x to the fourth plus 2 0. Okay, well, actually it can never be 0, because notice that, let's just say this equals 0. That would be negative. X to the fourth would be negative. The only way we can do that is with a non-real number. So since x to the fourth, x is a real number, this is no solution. So the denominator is always positive, so that means no vertical asymptotes. So what that means is this is all actually a continuous function. This is all one connected piece. Where does it cross the x-axis? X squared minus 8 is 0. X squared equals 8. X is plus or minus the square root of 8. 8's 2 cubed, so this is 2 square root of 2. So we have some things. Actually, this one, notice this one also has all even power, so it's going to be symmetric about the y-axis. So wherever it's going to cross here and here, eventually it's going to come down this way. Eventually it's going to go this way. So it must do something like, well, let's see, it only crosses twice, and I'm sorry, I've got this arrow on the wrong side here. I said something wrong here. On an even power, if it's just this one, it would look like this. So it's going to be it's going to be above here. So I think this one looks like that, and those are multiplicity 1 roots. Okay, so it's going to look like cross here and here somewhere. It's going to be coming in here on the outside, here on the outside. So it must be going up, down, 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 up, like that. So it must look something kind of like that. It should be symmetric about the y-axis. We could graph it and see with the graphing calculator, or just plot a bunch of points by hand. Okay, I think that wraps it up. I went over a few extra things along the way that, of course, you didn't have to do. Like, for example, here I talked about the vertical and horizontal asymptotes, if it had any, or x-intercepts and shape of the graph. So I did a little bit more than you had to, but hopefully you can use this and help you study. And we'll come back for Part B video here in just a little bit.